Unit 3, Video Lecture 2, Atomic Structure. Atoms are not solid structures. They can be broken down into subatomic particles, as was shown by J.J. Thomson. If we consider a submarine travels underwater. The word submarine can be broken down into sub, meaning below or under, and marine, dealing with the sea. So the word subatomic can also be broken down into sub, meaning below, and atomic, referring to atoms. So subatomic particles would be particles that are smaller than an atom. So what are our subatomic particles? Well, there are three of them: the proton, the neutron, and the electron. The proton is found in the nucleus. The neutron is also found in the nucleus. Oh, time out, go back. The three subatomic particles are the proton, the neutron, and the electron. The proton is found in the nucleus and has a positive charge. If you notice, proton and positive both begin with the letter P. So protons are positive. Protons have a mass of 1.00 AMU. AMU stands for atomic mass unit. Now, protons, neutrons, and electrons are so small that it just is not feasible to measure their mass in grams, which is what we would normally use. Normally we would use things like grams, milligrams, kilograms. Well, those are just way too small, so we use our AMU, our atomic mass unit. The neutron is also located in the nucleus, and the charge is neutral. Now, if you take a look at neutron, it begins with N-E-U-T-R. Neutron. Well, neutral refers to N-E-U-T-R. So neutrons are neutral. The neutron also has a mass of 1 AMU, 1 atomic mass unit. The electron, as we know from Rutherford's model, is outside of the nucleus. It's in the electron cloud. The charge on an electron is negative, as we know from Thomson's experiment. The mass of an electron is very, very small. It's so small, in fact, that we actually consider the mass of an electron to be 0. So the structure of an atom has electrons, the negative charges, in the outside, the proton positive charges and the neutron charges in the center of the atom in the nucleus. Now when we look, a neutral atom, a standard atom, will have the same number of protons as it will neutrons. So here we see 1, 2, 3 protons, 1, 2, 3 electrons. If we look at a cell on the periodic table, we see a 6, we see a number, we see a symbol, and then we see a second number. This first number here, the 6, is the atomic number. The atomic number is equal to the number of protons that are present in an atom. The black letter is the chemical symbol. This blue number, the 12.01, is the atomic mass. Now, the atomic mass is the weighted average of all our naturally occurring isotopes. This is different from the mass number. The mass number is the number of protons and the number of neutrons. How do we figure out the mass number when compared to the atomic mass? It's very simple. We take the atomic mass, 12.01, And considering the fact that we cannot have 0.01 of a neutron or a proton, we have to round to the nearest whole number. So 12.01, we look, the mass number of carbon would be 12. If we consider some other elements, other elements like lithium, lithium's atomic mass is 6.94. So, the atomic mass is 6.94. If we want to calculate the mass number here, we take 6.94 and round it to the nearest whole number. So we take 6, look to the right, the 9 tells us 6, the mass number of lithium is 7. So, we should be able to figure out the atomic number, the mass number, the number of protons, the number of neutrons, and the number of electrons of elements. Let's take neon. Neon has an atomic number of 10. When we look at neon, the atomic mass is 20.18. Rounding this number to the nearest whole number, the mass number of neon is 20. The number of protons in neon is equal to the atomic number. To figure out the number of neutrons, we take the mass number of 20 is equal to the number of protons plus the number of neutrons. So the mass number is 20, the number of protons is 10, so what number plus 10 will give us 20? Neon has 10 neutrons. We also know that the number of electrons equals the number of protons. So the number of protons is 10, so neon has 10 electrons. A mass number of 7. Looking at our periodic table, we find the closest number that will round to 7 to be lithium. Lithium's atomic number is 3. Since its atomic number is 3, it has 3 protons. So again, to figure out the number of neutrons, 7 equals 3 plus some number. Lithium has 4 neutrons. The number of electrons is equal to the number of protons. Lithium has 3 electrons. An atomic number of 19. This is potassium. Looking at potassium, potassium's atomic mass is 39.10, so this rounds to 39. The number of protons is equal to the atomic number, so 19. Neutrons plus protons will give us our mass number. So what number plus 19 will give us 39? That's 20. And the number of protons is equal to the number of electrons. Hg is mercury. Mercury has an atomic number of 80. Looking at mercury's atomic number, atomic mass, it's 200.59. Since we're rounding to the nearest whole number, mercury's mass number is 201. The number of protons is equal to the atomic number. So what number plus 80 will give us 201? Mercury has 121 neutrons. And the number of protons is equal to the number of electrons, so Mercury has 80 electrons. So let's practice. The element nitrogen, what's its atomic number? Nitrogen's atomic number is 7. The mass number is 14. So 7 protons, 7 electrons. 14 equals 7 plus 7. An element with an atomic number of 16 is sulfur. Since we have the atomic number of 16, we can fill in the number of protons, which is 16, and the number of electrons, which is also 16. The mass number of sulfur is 32. So what number plus 16 will give us 32? Now in our third example, we have 30 protons. From this we can figure out the atomic number. The atomic number is also 30. We can also figure out the number of electrons, which is 30. The element with an atomic number of 30 is zinc. This mass number here is 30 plus 34. So 64.